Okay, people. I've had numerous technical issues. So anyway, that's the way it goes sometimes. So today we're going to be looking at different types of energy waves, and we've been looking at cosmic explosions and the sun and things like that in space. So how do we see these things? Okay, so we're just going to have some information about the basics of energy waves. It's all from energy waves. Okay, so it's one kind of energy wave that we're familiar with is light energy, but there's many more types of light, quote unquote, light energy. They're called electromagnetic waves, and there's many more that we cannot see. And all energy travels in these waves. That is how energy travels. Light wave, microwaves, sound waves, just all energy waves in the ocean. They all end up traveling in these types of waves, this energy. So the difference between them is really the length of these waves, how it is from top to top. These are longer wavelength, and the shorter the wavelength, the more energy it takes to produce them. But volume sound is the height of the wave, and the type of energy wave it is the distance between the tops of the waves, or the bottoms of the waves, or the middle of the wave. Okay, that is the type of energy wave it is. But the sound, the volume is how tall they are. Okay. So radiation in the videos, right? The energy wave, which is also called light or light radiation, is that we've been seeing. Okay, are called. They've been using the kind of energy wave called electromagnetic wave energy, or electromagnetic radiation, has also been said. Okay, it sounds technical, but it's really not. It's just a type of energy wave. All those waves have the same characteristics, right? How long is the wavelength, and how that gives you the different types of energy. Okay, how long the wavelength is. Okay, so it may surprise you to know that the tools that captured these energy waves in these images that we've seen in videos, okay, they do not use light that we see with our eyes. They transform the information they get to light photos that we can see with our eyes. But with the first capturing it is not in the instruments, is not the light energy that we see. It's other types of light energy, also called electromagnetic energy. Okay, the energy waves that humans use to see things we call light. But actually there are many types of light radiation other than that what we can see with our eyes. So there's a lot of light radiation out there that we cannot see. Our eyes are evolved to only see a small portion of the light radiation, okay, that exists. All energy waves have the same characteristics, okay, so we're not going to worry about that technical aspect so much. We'll just look at these different types of energy waves to get us a sense of what's going on, that these instruments in space are getting, they're detecting a type of energy wave that we cannot see with our eyes. Okay, so our eyes have cells that they vibrate or resonate when different colors hit them, which are different wavelengths. The different colors are different types of radiation called electromagnetic energy waves. There are many, many more electromagnetic energy waves than we can actually see. Our skin has heat cells that can detect a type of energy wave, infrared radiation. Oh, that's supposed to be example 2. Oh my gosh. That is from heat. If we don't have these cells, we don't detect heat, even though it's there. I should have made that example 2. So there are a few people born without these cells that detect heat, and they cannot feel heat. Okay, they can easily burn themselves. And then we have a third example to give you a feeling for these energy waves and how we only can detect a few of them. Bugs and snakes can see in different types of light waves, just like in example 1. Viper and python snakes have 2 pairs of eyes. One pair is like normal light that we see, and then the other pair is for a type of energy wave called infrared radiation, which is a kind of radiation that comes from heat. Infrared radiation shows heat. They use this to find prey and kill the prey, and then that's how they live. So when a snake sees the night sky, it sees more types of light than we do. It looks up and it also sees this infrared radiation. What would that look like, I wonder? Anyway, moving on. Example 3 of energy waves. Water organisms will definitely have eyes that detect different types of light radiation. So they'll see things that we cannot see underwater. Example 4 of energy waves is ultraviolet radiation, which can cause skin cancer. It's a very strong energy wave, and your heat detection cells in your skin do not feel that ultraviolet radiation. Even though it's so strong, you would think we would have something to detect them, but we don't. The energy from ultraviolet light is not detected by our heat cells because ultraviolet radiation is a different type of energy wave than what our heat cells in our skin are made to detect. I don't think we have any cells that are made to detect the energy of ultraviolet radiation, even though it is a dangerous type of energy wave. Okay, so that ultraviolet radiation is a type of electromagnetic radiation, which is also like light, many types of electromagnetic radiation. But we only can detect a few of them. And again, that's a type of energy wave. Other examples of the energy waves called electromagnetic waves: radio waves, radar waves, right? Radar, microwaves, X-rays, and there are more. Okay, so example 5 of energy waves is sound waves. Okay, so they travel. These are energy waves. They travel through air, and they push and they pull the air, or water. Even you can hear sound underwater. Whales do, dolphins do. This pushing and pulling of air molecules moves our eardrums, and we hear it. So we call that sound. Some sound waves are too small or too big to move our eardrums, so humans don't hear them, but other animals can. For example, shortwave sounds are heard by some insects, bats, some birds and dogs, and maybe dolphins and whales for shortwave sound. Longer wave sounds are heard by elephants and maybe whales and dolphins and other animals. So there's all kinds of energy waves. Some are like light energy, it's a small portion of electromagnetic waves, or sound energy, sound waves, and we do not see or hear all of them that are occurring out there. So that's the main point. There are many types of energy waves around us, so we do not have any way to detect them. So this is also true for cosmic explosions in our sun. They emit many types of radiation that we cannot see or feel. So we use technology with instruments that can capture these different kinds of radiation, these different kinds of energy waves. The type of radiation we detect in the images and measurements of cosmic events in our universe is called electromagnetic radiation, a type of energy wave called electromagnetic radiation. We can see a small bit of all this different types of electromagnetic radiation, but there's a lot being emitted that we cannot see. Different types of radiation are grouped into wavelengths. Humans break up the light radiation we can see in different groups called colors. Humans break up sound wave energy into groups called musical notes. We break up heat into temperature groups called degrees, 1 degree Fahrenheit or 1 degree Celsius. So these types of energy waves that we can detect, this is what we call them. So the world we see is really very limited. There's much more to see or hear or feel that we just are not built to perceive. We are blind to other types of energy waves of light or sound or heat. And now we have technology that can help us perceive them these other types of energy waves that we cannot perceive. So cosmic events like exploding stars or our sun burning or different cosmic explosion release many different kinds of radiation. This radiation is called electromagnetic radiation and is grouped into different wavelengths. So here's some, so there are waves, and then the lengths of these waves, that is what really tells us what kind of electromagnetic radiation it is, or what kind of energy wave it is. And as I said before, the power of it is the height. You get, if this wave was higher, then that would have more power, but it would still be the same type of energy wave. Okay, so here are some instruments in space that are capturing all these different kinds of electromagnetic waves that we cannot see. Some of them we can see, is light that we can see, but some of them we cannot. So like the instruments over here, they're capturing these very short wavelength energy waves, and those are very powerful. When you get over here, these very tiny energy waves with small wavelengths, they're very, very, very powerful. And then radio wave, we're radio wave, they're all the way over here, very long energy electromagnetic waves with long waves. Okay, and then we talked about light. So the cells, here's a human eye. The cells that are here, that are in the back of our eyes, they can only detect very specific electromagnetic wavelengths. We're very limited to what we can see. Then we have heat receptors in our skin that can detect infrared radiation, very specific, but not other types of radiation. Like you would think ultraviolet radiation, which is very powerful and can be dangerous, you'd think we can detect it, but we can't. And scientists really are not sure exactly totally how our heat and cold reception works yet. So they're still learning about that. Snakes, they have these regular eyes to see regular light, what we see, and then they have these pits that can detect heat through infrared radiation, a very, very specific energy wave, electromagnetic energy wave, to help them hunt. And then we have sound waves. Elephants can hear these longer wavelengths. This is hertz. This is a measure of the kind of power, how energetic, I'm going to say, the energy wave is. So these are long waves with less energy to them, but elephants can hear them. I'm sure dolphins, whales can hear these kind of long wavelength energy waves. And then we have ours that we hear. And then bats and insects and some birds can hear these very short wavelength energy waves. They call those high frequency. Okay, so your question today is going to be, if a child came up to you and asked you to explain how we can see exploding stars, how would you explain that to them so that they understand that some types of light energy, electromagnetic radiation, cannot be seen by our eyes but are being emitted by exploding stars, and we have instruments that can detect them? Include examples of energy waves that occur but we cannot detect them. One thing I did not mention here is that when these instruments detect electromagnetic radiation, we use computers to change that to a photograph. So we change these electromagnetic wavelengths that we cannot see. They change those on a photo to our visible light wavelengths so that we can see what was captured in these photos. Okay, that's that for now. I will put this on, I'll add it to Teams as a file. You can see files on there. I have to figure out how to do that. I'll put it on OneNote also, but I don't know if, I'm not expecting you guys to be able to go on OneNote. Okay, that is it for now. That's a bit long.